All right, we are recording. It is Monday, April 27th. And we are basically entering our second last week. Actually, there's 2 weeks and a day left of the semester, right? And you can certainly, I hope you have been referencing the revised lecture schedule, so you kind of know what we're doing week by week. So we had started cardiovascular early in the week. Last week we had the exam on Friday. And so this week we've got cardiovascular scheduled, which is at chapter 15. And then we've got all of next week and that following Monday, the 11th, which is our last regular class day, scheduled for lymphatic system and immunity, which is 16. This is kind of a loose schedule, but it, of course, gives us some idea of kind of what we hope to get through between now and then. So that fourth exam, we're going to have to decide what day that is going to be held. And I'm thinking probably, let's see, the 12th is a Tuesday, the 13th is a Wednesday, the 14th is a Thursday. I'm kind of thinking probably toward the end of that week, like maybe the 14th. So we have only 6 people here, which is sort of sad. So it's going to be tough to pick a date and the time and secretly hope that everybody's in agreement with it, because I can guarantee you we'll pick a day and a time and somebody will have an issue. But it is what it is. So I would like to throw out at this particular time the idea of having the exam on the 14th. Not that we couldn't potentially alter that a little bit to the 13th maybe, but there's no point in having it right after that Monday's class on the 11th. That just doesn't make any sense to me. So I'm thinking the 14th, and as to a time, we'll just, give more thought to that. I think, what did we do for the exam last week? We had it open from the noon, 6 or 5 or something.
It was, yeah, 6 to 10. Right.
Oh, was it 6 to 10 p.m.?
Yeah.
Oh, okay. All right. I did not remember. There were a few people I think that couldn't take it then, so I had adjusted it a little bit earlier in the day. Okay, so I'm going to just, for the time being, put something like 6 to 10, and I'll put question mark, and then we can talk more about that on Wednesday. Maybe I'll send an email out today suggesting that time, and we can refine it, but let's just tentatively say Thursday the 14th for now.
So is that like the final exam or just the last couple chapters?
That's going to be the 4th exam. We won't call it a final in the sense of it being cumulative.
Okay.
So we're going to call it the 4th exam, and that's going to be basically over chapters 15 and 16, because we put blood on the last test. Okay. Now there's positives and negatives to this. The positive, of course, is only 2 chapters. And I wouldn't call it a negative, but the disadvantage is that's a lot of points on just 2 chapters. So you're going to have to really, know the material, because we're spreading it out over less space, if you will, than we did on the previous test, where we had 4 chapters or 3.5. So it's just something to be mindful of. All right, so any questions on the tentative time, the 14th of May, 6 to 10, something like that, and I'll send that note out to everybody and see what conflicts, if any, there are.
And but the practical's then on the 11th, right?
That's
what I have on my schedule.
Yeah, no, that's true. That's what I've got on here as well. And
Okay.
that is a Monday, isn't it?
Yeah.
Yeah, it's a Monday. I don't think it has to be that day, although we could have it that day, or we could put it on the 12th, Tuesday. Let me think a little bit about that,
Okay.
but I appreciate you bringing that up. Just make a note to myself here. I mean, what do you guys think about having it like on maybe the 12th, or would you rather have a few days between the practical and the next exam? What are your thoughts? Because I really will do what you'd like to do. Does it make a difference? Do you want to have it on that Monday and then have the test on Thursday, or would you rather have it on Tuesday, the practical, and then the test on Thursday? Does it make a difference?
I would like a few days in between.
Mm-hmm.
Yeah, that sounds good to me.
Would it be better to have it on Tuesday though, so that we could talk about the lab? Because I feel like we've been talking about labs on Monday more so. Does that make sense? Like for
Yeah,
the week.
we actually probably have, because that's the beginning of the week.
Right.
The other thing that I could check into, I don't know the answer to this question, and that is, when do the final grades need to be submitted by? Usually it was that Friday of finals week.
I think that's what it said in an email I got.
Oh, okay. So, I was thinking, well, we could push the test off until the 15th, but then I'm going to be under the gun to get it done and everything submitted that same day. And I think that would be just a little bit tough to do.
Yeah, I'd rather do it like a Thursday anyway.
Yeah.
Yeah, I think we're almost going to have to do that to give me time, because I've got other classes that I've got to do stuff for too. And that Friday just, it's right away the next day. So back to the question of the practical being on Monday or a Tuesday.
I guess maybe if we just opened it up after like our Zoom meeting to give us like a last chance.
Yeah, no, I understand what you're saying. We could plan it for Tuesday as well, and you could have, part of that Monday if you wanted, after we talked, to have time.
Right. That's a good idea.
Why don't we do that? Let's schedule the practical for the 12th. That's Tuesday. And I'll give thought to the timing, like what time of day. I have to go back and see what we did last time. Okay, great. So, are there any questions on that stuff?
No.
Okay. Okay. Very good.
Oh, actually, not really on the practical or the exam, but the extra credit paper is due the 6th. Did we figure out how we're gonna do all of that?
You mean the submission?
Yeah.
Yeah. What we're going to do is we're going to use Dropbox in Blackboard, and
Okay.
I have talked to our IT guru about this weeks and weeks ago when I was investigating how that might happen, and because it was not an immediate thing, I did not take notes from him as to how that gets set up. But I will say, in microbiology, the students have a report due this week, and I haven't talked to them about it either, but I've seen that there are 3 people that have submitted it, and it went to the grade center. So I'm not sure if there's going to be a whole lot of things that I have to do. I maybe have to just inform you guys to go here to drop it in, and so it's not going to be a big deal. You guys have probably already used Dropbox for some of your other classes.
Yeah. So you want copies of the articles and the site, work site and everything, like all in one document into the Dropbox?
So does the Dropbox allow you to drop obviously different documents in at once, right? Like you could submit the paper, that could be one Word document, then you could submit another document.
Yes, it does.
Oh, it
thought
does.
I
I
thought
wasn't
it's
sure.
only one.
I thought it was only one too, but
So
I've never really tried it otherwise.
you would just have to like put another page at the end of, say, like you have your paper and then start a new page and then put your sources. And then how we usually do it is then you submit it. So it has the sources at the end of the paper.
Yeah, but I think what Juliana might be asking about is not so much like the bibliography. You're talking about this.
Yeah, you want the actual articles, right?
Well, I would like the highlighted parts of those articles that you directly use for the paper. I don't need all of the articles.
Okay.
Because that's going to be a pain in the butt for you to have to scan or whatever. I just want to see evidence of you not plagiarizing.
You
So
just want like the quote or something then.
Depends on how you utilize the source.
Okay.
So let me clarify, get some clarification on this for next meeting, as far as can you submit multiple documents at the same time or how that all works. So I'll check on that. Okay.
Okay.
Just making some notes here to myself. All right. So yeah, I'm glad that you brought that up because we do want to make sure we get that submitted by the due date so that I have obviously time to read that. And that was the 6th, you said?
Yeah.
You said that was due by 5 p.m. I have here on my sheet. Okay, just to clarify in case you didn't know the time. Okay.
what was due by 5 p.m.?
Pardon me?
What was due by 5 p.m.?
The paper, if you're doing an extra credit paper.
Oh, okay.
On the syllabus, it says due May 6th at 1:15, which is when we would have met for class. But somewhere along the line, we must have talked about this, I think, and I extended that to 5 p.m. Maybe did I tell you about that, or I can't remember. If we talked.
I don't remember, but that's fine.
Was it maybe in like the initial email when this whole thing first started? You might
Yeah,
have said it.
yeah. So maybe make a note, May 6th, 5 p.m. Everybody else who didn't know that should have it in by 1:15 because that's what the syllabus originally said. So, okay. Okay, anything about the extra credit?
I think so.
Okay. So maybe we should begin, as Juliana has indicated, to talk a little bit about what we're doing in lab this week, which, according to the syllabus, would be exercises 37 and 38. Blood cells and blood typing was 37, and heart structure was 38. We've already started talking in the voiceover PowerPoints about heart anatomy. And we've talked about blood cells back in the blood chapter. So quite a bit of these two exercises is going to be stuff you have heard of before. So let's just take a look at 37 first. If you go to the Blackboard course shell, which I'm going to share, let's see here. I will show you what is in Blackboard. Okay, all right. What are you seeing on your screen right now?
Home screen.
Okay, great. So go to content, go to, are you seeing this now? Stuff to copy and bring to lab?
Yep.
Okay. And then of course, we scroll down to this folder. Everybody see that
Mhm.
in pink? Yeah.
Yeah.
Okay. And then in there are several videos that review blood counts and different types of white cells that we've again talked about in the blood chapter. This is actually taught by a nurse, but I think it's well done and talks a little bit about the CBC that one would get back from a lab if you take blood from a patient and you get the complete blood count and complete blood data back. So a lot of you guys are going into nursing, so you're going to be hearing about this. So I thought that would be a really nice reference for you to kind of hear about. And then another part of this exercise 37, which we would have done had we met, is you would have had an opportunity to have your blood typed. And so this short video goes through the different types of blood in humans, you know, the A, the B, the AB, the O. It also talks about the RH factor, which would be the plus or the minus, right? Somebody who's got blood type A positive, the positive refers to an additional antigen. It's called the RH antigen. That RH comes from the animal that it was first discovered in, called the rhesus monkey. That's what RH stands for, rhesus. Also, you might remember when we did the blood chapter, I said I'm not going to lecture on the last part of that chapter that specifically talked about blood typing. So if you go in the textbook to chapter, blood chapter was 14, on page 550, there's a section entitled 14.5 Blood Groups and Transfusions. And so you might want to read that short section and then watch the video. That's what I would recommend you do. And that'll kind of walk you through, again, the different types of blood and why you want to avoid certain sorts of transfusions, because you could end up with what's referred to as agglutination or clumping of the blood. And that would be due to antibody-antigen interactions that cause the cells to all begin to clump together. Now, a lot of students confuse agglutination or clumping with clotting, and that's a totally different process. So do not connect those two. Clotting, we know, is a result of fibrinogen getting converted into fibrin. Remember that, the last part of that complex extrinsic intrinsic clotting mechanism we talked about back in the blood chapter. Agglutination is very, very different. This has to do with certain antigens, the antibodies attaching themselves, and the cells link together and they clump. They don't clot. So that video is there.
What page did you say that was
That's
on?
550 through 554.
Okay.
Yeah. And then I've got, well, let's see. As long as we're in the blood exercise, let's just continue talking about that before we get to 38. So 37, if you have your book, your lab book, flip to that exercise, and what it does is it reviews the formed elements. They're on figure 37.1. And what are the formed elements?
Red blood cells, white blood cells.
Platelets.
That's right. The three major types of blood cells. Those are the formed elements, right? And so this figure has a variety of photographs of the various types of white cells. And remember, we can group white cells based upon the presence or absence of granules in their cytoplasm when you stain them, right? Does anybody remember which of the white cells were agranulocytes? Meaning they lacked the granules.
Was that basophils?
Nope.
Darn it.
Lymphocyte and monocyte.
Yeah. Lymphocytes and monocytes are agranulocytes or agranular leukocytes. Same thing. The other three, the basophils, eosinophils, and neutrophils, all have stained granules in their cytoplasm. Now again, I want to reiterate, these granules only appear if you stain the cells. If you look at a fresh blood sample from yourself under the microscope, you're not going to see the granules, okay? You'd have to add a special type of stain called right stain and then look for them, okay? Now, if you didn't stain your cells, your white cells, how would you go about trying to determine which of the 5 types you might be looking at if you're looking at a single cell? What criteria could you use to help you narrow it down?
Size?
Size, yeah. Because remember, lymphocytes are not much bigger than red cells, so they're small. So size, yeah.
Quantity found?
Well, yes, after you counted them all up, you'd find that the most abundant type would be the neutrophils. But let's say you're just looking at your first one. Odds are, right, odds are it's a neutrophil, odds are, but don't go by odds because you could be wrong, right? So
The shape of the nucleus.
right, shape of the nucleus, that's a really good one to look for. Does it look like a kidney bean? In which case it might be an eosinophil. Is it multi-lobed? In which case it's a polymorphonuclear leukocyte. Well, what the heck is that? That's a mouthful. Polymorphonuclear is the same thing as what? Polymorphonuclear, many-shaped nucleus. That's a what? Anybody? Take a guess.
Neutrophil.
Monocyte?
No, neutrophil.
Wow. Darn it.
Neutrophil. Neutrophil. Neutrophils. Look at that photograph. Upper left-hand corner of the page. See the different lobed nuclei in those 3 cells? Yeah. So that's why some books, and maybe it's not so well used or widely used today, but they used to call these cells polymorphonuclear leukocytes. Now it's more commonly just referred to as neutrophils, but I think the other term was aptly named, even though it took forever to write it all out. So I will just simply tell you, I am not going to put a photograph of a neutrophil on a test and ask you to tell me what type of white cell it is, but I think you should be familiar with how one would differentiate between them under the microscope based upon what we just talked about. On the opposite page of that figure 37.1 are 2 tables. One that lists the cellular components of blood, which is just a basic review of the formed elements and what their functions are. So you should certainly be able to recognize that information in that table. Again, nothing new here. We talked about a lot of this in lecture. And then the other table, it says differential white blood cell count, and it lists the 5 types of leukocytes and their approximate percentages in an adult's blood, count, and also what some elevated percentages might be indicative of if a person is suffering from an infection or cancer or whatever the case may be. So I would again spend some time looking at that table. So if I were to ask you, for example, statistically, what is the least common white cell? You should be able to tell me basophils, just like neutrophils are the most common, the most abundant of the 5. And these various normal percentage values, I think we talked about these back in the lecture too. So you could really just go back into your lecture notes, back into the blood chapter, and get all of this there too. So this is just a review for the most part. Now, had we met, we would have done the blood typing, as I said earlier. We would have also done a hematocrit. Do you know what that is? What is a hematocrit?
That's putting the blood in the little tube, right?
Yeah, we talked about this back at the beginning of the blood chapter. It's where you take a small sample of blood, you place it in a heparinized microcapillary tube, and you plug the one end with a little piece of clay, and you put that little tube into a microcentrifuge, which will spin that blood down. I think we spin it for about 3.5 minutes at a very high RPM, and then it comes out. And Sarah's done this before, so she's more familiar with it than you guys are, I think. And what will you see when you pull that little tube out? You're going to see the same thing that your book shows there at the top of page 531, right there. There's the hematocrit. That's the packed cell volume. So all of the red cells, which of course are the most abundant of the formed elements, because they're heaviest, they fall to the bottom of the capillary tubes. There's a little clay plug there at the bottom so the blood doesn't fall out, right? Have to plug that in. This end was open at the top. And this packed cell volume or hematocrit should be around 45% or so. And then just above that was a little buffy coat, making up less than 1% of the entire volume. And then above that, of course, was the liquid plasma, making up more than 50% of the blood volume. So what's that buffy coat between the plasma and the red cells? What is that got in it?
White blood cells?
Yeah, what else? White cells and what's the other formed element?
Platelets?
Platelets, yeah. Mm-hmm. Yep. So what's really interesting about that, and I think it just visually brings this out in the best possible way, is you can just see how much more abundant red cells are in your bloodstream than are white cells or platelets. That is not to diminish the importance of white cells or platelets, is it? Because we know they're extremely important, but we don't have nearly the number volumetrically of white cells and platelets as we do red cells. There's just a ton of red cells, comparatively speaking, in the bloodstream than there are white cells or platelets. So we would have done that, and that's really kind of fun. Students really enjoy doing their hematocrit, and I'm sorry that we can't meet and do that test. So we would have done that. There's also a real quick and dirty hemoglobin test that we would do. It basically involves taking a drop of blood from your finger and putting it on a piece of paper, and you let that dry for 10 or 20 minutes. And then you would put that underneath a special sheet of paper that would have different color blood samples, photographs basically, with little holes that have been punched in the middle of each of the colors, and you'd put your blood sample underneath so that you can see it through that little hole, and you would just basically match up the color. So generally, the darker the blood, the higher or the less the hemoglobin, the brighter the blood, the more the hemoglobin. So it's more of a color thing. It's not very accurate, but it would tell you whether you were like really, really anemic. If you were super anemic, you could probably see that on this little piece of paper, the drop of blood, comparing the colors. It's really not very accurate, but I tell the students, hey, if you're bleeding and you want to do another test, put a drop of blood on this and we'll just kind of do a quick dirty comparison to see if you're anemic or not. And once in a while you get somebody in class who is anemic, and then we can show everybody else, hey, this is what an anemic blood looked like compared to most people's blood, which is, of course, getting adequate oxygen. So we would have done probably three tests in lab had we met. So anything on exercise 37?
I don't think so.
Okay. Then let's talk about 38, which is heart structure. And I'm going to go back to sharing the screen to tell you about a Word document. Do you all see this?
Mm-hmm.
Okay, I'm going to just open it up real quick. This is a document that has a list of heart structures that we would have looked for and identified on a heart model. And I know this looks like a pretty daunting list, but it's really...
We actually can't see the list.
Okay, I'm glad you said something, because now here we go again, right? Why doesn't it do that? All right, hang on. I'm going to stop share, and I'm going to try it again, and we'll see if it works this time. How about now?
Yeah.
Okay. Doesn't like those Word documents.
You like zoom in a little bit?
Sure.
Thank
You bet. How's that? That better?
Yeah.
Okay. So what we have here is a list of structures, some of which are on the surface of the heart. Some of these are internal, but they relate to heart anatomy. Okay. And again, I know at first it's like, holy moly, how am I going to learn all those? It's not as bad as it looks. It really isn't. What I would recommend you do is go to exercise 38 and I would use your textbook. So you have to go to chapter 15, which is cardiovascular system. And in the beginning of the chapter, there are some labeled diagrams there on 567. I see there's some labeled 562, 564. I'm sure you could find the same diagrams in the lab book that are in the textbook. And I would simply label, let me stop sharing for just a moment. I would simply go in and I would start to label those lines that don't have terms next to them. Okay, on these three figures. And then what I would do is I would, after I've labeled those figures, in fact, you could also even do the heart model there on the next page too, so there's actually 4 figures. Once you've got those labeled as best you can, then I would go back to that list of terms, okay? And I would highlight those terms that appear on this handout, on this sheet, this Word document, that are also found on those diagrams. So you're basically learning those structures that you need to know, and you're omitting those structures you don't need to worry about. Does that make sense?
Mm-hmm.
Okay. And just spend some time getting a little comfortable with the anatomy. Then I would go to this set of videos here. Does everybody see the heart anatomy part 1?
Yeah.
Okay. This is the model that we would have used in class. It's the very same model, same one. So as you play this, as you see a number, like this is the left atrium in yellow. Here's the pulmonary trunk in blue. I'm not saying you have to put those numbers on the Word document sheet, but that's what we would have done. It should be the same numbers on this heart as it is on our hearts. The company that makes them should be labeling with the same numbers. So anyway, you would have done that. So if you've studied a little bit of the anatomy based upon those 4 figures, then when you watch this video, you're going to be like, oh yeah, I see exactly what he's pointing to. Oh, I understand when the blood is ejected from the right ventricle, how it enters this pulmonary trunk and then how it splits into the right and left pulmonary arteries, and that takes the blood to the surrounding lungs. And then when the blood comes back after being oxygenated, it enters the left atrium here through 2 pulmonary veins on this side, and there's also 2 pulmonary veins on the opposite side that he'll point to. It's going to make it much more understandable, I think, if you've just taken some time to try to learn the anatomy from the diagrams and then watch the 2 videos. And then this last one is again something that we would have done. We would have done an actual heart dissection. I would have used deer hearts. If we run out of deer hearts or don't have them available, we would use sheep hearts. And here you see a sheep heart. The reason I don't like to use sheep hearts is because you can see how the color is really, it's not indicative of the nice, beautiful red color of a normal heart muscle. It's pickled, it's preserved, right? And it's not a bad thing to use, but I would much rather use a thawed deer heart because it looks just, the structures look just so much nicer and better than a preserved heart. But anyway, this is worth watching. This is really interesting. So you should definitely check that out. So that's basically what's on the docket for this week in terms of lab. Questions?
No.
Again, there's really not a whole lot new here, other than maybe a few blood vessels that we didn't talk about in the voiceover PowerPoints, because I posted 2 of them already for chapter 15. The nice thing about this is that, you know, you're studying the heart and so forth here for the quiz next week, but you're also studying this for the practical in 2 weeks, and you're also studying this for the lecture exam. So it's like killing 3 birds with 1 stone kind of thing. If you put the time into this for lab, it's going to pay big dividends when you get to that 4th exam. So the heart anatomy is super critical to really get down pat. Before I forget, I just thought of this too that I wanted to point out to you. I think I can find it quickly. Let me see. There should be a diagram of the heart. Question is, can I find it here? Oh, there it is. Folder, heart diagram and anatomy dissection video. Oh, this is what I had before here, didn't I? Okay. This is something that I had saved earlier, I think, a couple weeks ago. Let me think here. I'm looking for just the diagram. There was a diagram you could print off. I think it's in this one. Here it is, heart, no, it's heart model. Where is it? Heart diagram. Somewhere in here is a diagram of the heart that you can print off, and you can label the chambers if you want to do that. Where the heck is it? I'll find it and I'll send it to everybody. I'll email it to you. Because some people like to have a diagram, you know, a blank one that they can label. So let me make a note here. I'll find it. I just can't find it right off the bat here. Okay, so any questions on lab? Those exercises.
No, I'm good.
I don't think so.
Okay. All right. Morgan, any questions? Morgan. Okay. Samuel, questions? Melissa?
I don't have any questions.
Okay.
I'm all good.
Okay. Thank you. All right, so let's turn our attention to the lecture stuff. And again, what I've posted in Blackboard are several voiceovers. So I'll go to content, go down here to the green font, chapter 15. And there you'll see two voiceovers that I did. I did one yesterday. I did this one yesterday. I did this one, I don't know when it was. Last week or late in the week. And then I also added a couple additional videos that I thought were kind of pertinent to this chapter. One, again, is from Arapahoe Community College. Some of you have looked at a similar lesson that they did, I think, on the blood. I forget where. I put it on one of the earlier chapters. This is quite lengthy. I don't remember how long it goes, but again, if you want to review it, it's there. This is talk.
I think it goes for like an hour.
Yeah. This one here, cardiac induction system, ECG, and regulation. This is from a different instructor, and I indicated here when to start watching this. And actually, this will review two topics that I talked about up in this voiceover, and that is cardiac cycle, cardiac induction system, and ECG. So again, just an alternative, additional review from a different individual using different diagrams. Doesn't hurt to hear it twice or three times, right, from different people. And then this last video is talking specifically about how you can have a procedure performed whereby they go in and they can open up some occluded coronary blood vessels. These are blood vessels that service the heart itself. Maybe you've heard of angioplasty before. If you haven't, you should definitely watch that video. Stents are what they leave there in place once they expand that little balloon. This little white structure is a balloon. And there's like a metal scaffold here that's around the balloon. And when they inflate the balloon, the scaffold extends out, and then they deflate the balloon, and the scaffolding, if you will, the metal scaffolding stays there. Okay, and then they just pull the balloon out. So you have like this little bitty metal stent that opens the lumen and allows adequate blood flow. It's really cool. Some of these stents actually will also emit a vasodilator chemical to try to keep the smooth muscle there open, relaxed. Most of the time when somebody has a stent put in, they don't last forever and they need to be either restented, well, they'll go back in after 4 or 5 years or whatever, and then they'll put another one in. So it doesn't typically last forever, but it is a very effective procedure. It's been around now for, oh gosh, I'm going to take a wild guess here. It's at least 30, 40 years. But they maybe have improved the technology. I'm not exactly sure if there's a whole lot of difference between an angioplasty done today versus 20 years ago. I'm just not sure. So that's what I've got for you thus far in the folder for chapter 15. I will plan on adding to that. So I got up through ECG the other day, and I'll be picking up with regulation of the cardiac cycle coming up. I'll probably do that later today or tomorrow, so that you know, as you're reading, you can keep up with it as well. So I'll just kind of open the floor for questions. Have you got any questions on cardiovascular system?
No, I got all my questions off last week.
Or if you'd like to review, you should be getting into chapter 15 by now.
So the
Go ahead.
the depolarization and the repolarization is what we see on the EKG report.
What you see on an ECG, let's pull up the PowerPoint. Okay, hang on, let me just get out of this. All right. Okay, do you see a bunch of hearts here?
Yeah.
Okay, great. So this takes you through the various processes that occur during one ECG. And you see that depicted, of course, here at the end.
Yeah.
So to answer your question, Juliana, basically what you're looking at here are various depolarization and repolarization processes. You're exactly right.
Okay.
Yes. What you're not seeing, and I want to make this really clear because students are often confused, when they see this ECG, they think they're seeing chambers of the heart contracting and relaxing. And they kind of are, and they kind of aren't. They are seeing the electrical activity that leads to the mechanics, but this ECG is not physically measuring the contraction or relaxation of any of the heart chambers. It's just a picture of the electrical information that's responsible for those processes.
Okay.
And I think it's very important to understand the difference.
Yeah. Okay.
So when we say, like, if I ask you, what does the P wave represent? Which is this first one right here. There's the P wave. How would you answer that? And I'm throwing that out for everybody. So there's the P wave. How would you describe that to somebody? P wave represents blank.
The depolarization of the aorta, or the arteria, or
Atria.
atria. There you go.
Yeah, it's depolarization of the atria. Yeah, don't put aorta. But you had the right first letter. Yes, that's exactly what it is. And that's the exact right answer. P wave is the depolarization of the atria. Now, of course, that means right and left atrium, right? That's plural.
Mm-hmm.
What if I asked you, what does the QRS complex represent? How would you describe that?
That's the repolarization of the atrium and the depolarization of the ventricles.
Which atrium?
Both, right?
You said atrium.
Atria.
Right. Yeah, I know, picky. But you got to use the right words here, guys. You do. So you're right. QRS complex is really two events, two things. It's primarily depolarization of the ventricles. That is a more significant event electrically. But as Sarah said, it also represents repolarization of the atria. And so that's what you're seeing happen here, aren't you? At the very beginning of the QRS complex. Notice that the atria are green. The green indicates repolarization. And look what's starting to happen here in the ventricles. They are becoming what?
Depolarized.
Correct, depolarized. And so there's two events going on here. Repolarization of the atria, followed by depolarization of the ventricles. That is QRS complex.
So basically, it's just that they have to happen simultaneously.
The depolarization of the atria actually occurs before the depolarization of the ventricles, but we're talking about milliseconds here, right?
Yeah.
It happens so fast, but it does happen before.
Okay.
Yeah. Milliseconds before.
And then the T waves are the repolarization of the ventricles.
Correct.
Okay.
Now, if I asked you, what physical event occurs following repolarization of the ventricles? Let's ask that question. You know what the T wave represents. You accurately said it was repolarization of the ventricles. That's true. But if I ask you, what physical event occurs as a result of repolarization of the ventricles, what would you say?
Diastole of the ventricles, the relaxation.
Yeah, good for you. Excellent. Good job. It's diastole. That's how you
Okay.
pronounce that.
Okay.
It's okay. Diastole of the ventricles, and as you said, that's another name for relaxation of the ventricles.
Okay.
You've been studying, haven't you?
Yeah, I've been looking through
Good
the
for you.
notes a lot. I did all the notes for the chapter, so.
Good for you. Good for you. Excellent. Good for you. So you're coming into this feeling kind of confident because you've been working hard at it, right?
Yeah.
Yeah, and that's what you should feel. You've got to keep up with this. You just cannot fall behind. You got to just keep plugging away. 2 weeks and we're done. So give it your all here, guys. Don't run out of gas when you can see the finish line. It's there. And this is something that we would have done in lab next week. Had we met face to face, we would have had a chance to measure our ECGs. And that's really fun lab too. I really like that. We would have looked not only for the different waveforms, but we would have also been able to measure, and I mentioned this in the voiceover PowerPoint, we would have measured various components here of the ECG. See where it says PR interval, QT interval, QRS complex? These are expected normal values that a healthy individual should exhibit when they have those evaluated. And we would have actually had our little machine calculate that for us, and it's fun. So, about other questions on cardiovascular? Are these videos playing for you okay? They should.
Yes.
Good. Yeah, these are really, really good videos. They're really excellent, I think. This is the angiogram I was telling you about, how we do the balloon angioplasty here. Here's that obstruction, because you don't see the dye. See how it's lighter in gray versus white?
Mm-hmm.
Yeah. Yeah, this is an interesting procedure. They do this, the person is kind of semi out of it, but still awake when they inject the dye and such. Yeah. How about heart anatomy? Any questions on heart anatomy, the chambers, the valves? You should have this down pat by Wednesday as best you can.
is this on the practice websites, the parts of the heart?
Is this on the practice website? Are you talking about the diagram?
Yeah.
I was looking for that earlier and I wasn't able to find it easily. So it's possible that's where it is. Are you
Okay.
finding it there? Or
No,
not?
I didn't see it there. I didn't know if there was like another website.
Let me just look here real quick. Well, there is a folder in there that's entitled Practice Websites, and it has links to some good websites that would go over different aspects of A&P, including the heart. Oh, okay. So let me share the screen. I found it. All right, share screen. Okay, do you all see the, it says heart diagram and anatomy dissection video? We were
Yeah.
here earlier and I just didn't see this first file. This is the file that I was thinking about that I was going to email you, which I still can, of course. If you click on that, it pulls up this printable diagram of the heart for you to label the AV valves and one of the semilunars and the chambers and all that stuff. I will still plan to download that and send it out to everybody and encourage you to label it because you're going to need to know the anatomy for the practical for the last exam. You need to know it. So that is there. And then let's see. These are two more videos I should probably just put into the bigger folder. I haven't looked at these for a number of weeks. I found them and I saved them because I thought, well, the day will come when I'll want to show you these when we get to cardiovascular. So I'll probably try to upload these when we're done today so that everything is in the folder for this chapter rather than it being kind of all over. I'll put this heart diagram in there too, okay? So everything will be in one folder.
I don't know who asked the question about it being in the practice websites, but yes, it is. If you go to the Wiley one, there's a place you can go in and just click into the heart diagram. And you can label everything.
So Sarah, show me where that is. We go down where?
When you're in content, go all the way down.
Practice websites?
Yep, practice websites, and that'll open a Word page or
Yeah.
Word document.
Okay.
I just posted a link to the to the website in the chat. I was looking at the same thing.
Okay.
Yeah, that's the one.
Which do you see the websites in front of you now or no?
No.
Okay.
No.
So it's a Word document. So let me do it again. All right, hang on. Boy, this is just not very user friendly, is it? Okay. Well, that's for microbiology. Don't want that one. I want this one. Oh, what the heck? Come on. Come on. That one.
Yeah,
And which one of these were you looking at?
the second one down.
The Wiley. Okay.
Yeah.
So if you go to that, it has a bunch of different, like, I don't know, click and drag things. I don't remember what's on here.
Yeah.
You have to like scroll down on the left-hand side to see it though. That's the only
Okay.
thing.
Okay. So those of you that are here, check out that second one. And Juliana said she put a link in the Facebook page.
Oh, I can put it in the, I just put it in the chat, but I can put it
On
in the
the chat.
Facebook page too.
Why don't you put it there too? Yeah.
Yeah, I just actually, I looked at the second one, the academic.pgcc.edu, and they
Yep.
have one there too.
Okay. I mean, there's a lot of them out there. I just chose, some that I thought might be helpful. If you guys come across stuff that you think are helpful and interesting and useful, please let me know and I'll add it for future classes. It might not help you this semester, but somebody next semester might appreciate it. I mean, there's a million things out there. It's to the point where I don't want to inundate people with too much stuff. You can get to a point where it's like, I don't want to see any more. I got enough. But some sites do a better job than others for different things. Okay, so back to the PowerPoint. Are there questions on any of the topics? Again, the voiceovers basically got up to this slide. This is where I'm going to start my next voiceover. But we can talk about stuff, later too in the chapter. It doesn't have to be what I've already covered. It can be anything.
I don't remember if you went over the parasympathetic and the sympathetic.
That's coming up, Sarah, in the next voiceover.
All right.
That's the next topic. Yeah.
I
Which,
just didn't
we
think
we could talk about that now, or we could wait until Wednesday, whatever. I mean, most people probably, I shouldn't say, I don't know how far you guys got in 15 yet, but if you have a question, I can answer it now too, whatever.
I just want to confirm with my notes here real quick. The parasympathetic branch is basically the brake, and then the sympathetic is the accelerator.
Yes.
Okay.
Yep. Now keep in mind, Sarah, and you've heard me say this, the other guys haven't. Even though we think of parasympathetic as brake, if we leave up on the brake, what can happen? The metaphor was, you get in your car, you start the car up, you put your foot on the pedal, you leave up on the pedal, still on the pedal, leave up on the pedal, because you want to get out of the parking lot without having to maybe touch the accelerator. So the point I'm trying to make is, you think of the pedal, the parasympathetic is slowing down, but if you put less pressure on the pedal, you will speed up a little bit, not super fast, but a little bit. So you got to just keep that in mind. You know what I'm saying?
Okay. So basically the parasympathetic has like different levels?
No, it's primarily braking, but if you send less parasympathetic impulses, that could speed the heart up a little bit.
Okay.
But if you want to speed the heart up to the point at which you need to assess this stressful situation that suddenly you find yourself having to deal with, right? So something happens to you, you're driving down the road at night. This is the story I always give. You're driving home at night after a night class, it's pitch black, it's rainy, it's dark, you can't see anything, and a big 10-point buck runs across the expressway in front of you. You've all had that happen. Deer crossed in front of us on the road, right? Yes?
All the time on mine.
There you go. Samuel is a deer magnet. Have you ever hit one?
Yeah, I have.
Yeah. Well, I tell you what, I've come close, but knock on wood, I have not hit one. But when that happens, does your heart rate go up?
Oh yeah, absolutely.
Yeah. And that's due to sympathetic nervous impulses. That parasympathetic won't speed the heart up that fast. No, that's sympathetic. That's the fight or flight response you've heard of. You've all heard of that. So not only does the heart speed up, but what happens to your respiration rate?
You breathe heavier and
Speeds up
stuff.
too.
Right. What happens to your pupils of your eyes?
Dilate.
Right. Why would you want to do that? Breathe faster, pupils dilate. Why?
you're getting more oxygen into your system, so you can either run or quickly punch it.
Okay, yeah. How about my eyes? My eyes aren't helping me run.
Good
You
point.
see what's in front of you.
Well, I can see anyway. You're right, Amanda, or Melissa. Just keep thinking. If my pupils dilate, what's coming in? More light. I can more accurately visually assess the situation, which could be critical as to whether I survive or do not survive this stressful, potentially dangerous situation, theoretically. So your body is priming itself for survival. This is a primitive reflex that is developed in Homo sapiens for hundreds of thousands of years, going back to our primate days. It's a survival thing. Yeah. Interesting.
Too bad the brain doesn't do much when you're stressing out about an exam.
Right?
Well, let me think about that a little bit.
Maybe there's a way we can figure out how to do that.
Well, what do
I
you?
know mine keeps me up at night instead of letting me sleep.
Yep.
Yeah. Well, that's where beer comes in handy, right? Or I don't know.
Yeah, that doesn't help much either, though.
No. Caffeine. How about that? Caffeine keeps you awake.
No, believe it or not, caffeine makes me sleep.
Wow.
Wow, that sucks.
No, I can literally drink a cup of coffee right before I go to bed, and I still go to sleep without any issues.
Well, I've gotten to a point now where if I say have a Coke for dinner, and I like Coke, I drink it once in a while. If I have it at 7 o'clock, I can't fall asleep nearly as well as if I had not had it. I'm just positive it's the caffeine in it.
I'm like that
wasn't-
with iced tea.
I never used to have that issue, but as I got older, it became more just, I knew I couldn't fall asleep as well. I started to connect the two. So.
My mom, she can't have caffeine after about 4 o'clock in the evening because it'll keep her up till 12, 1 o'clock.
Yeah, your tolerance for things changes. Other questions?
Yeah, I know the cardiac pacemaker cells has to do with sending impulses.
Mm-hmm.
But what is their primary function, or is that the primary function?
The primary function of the pacemaker, the SA node, is to initiate and distribute impulses.
Okay.
So it is often thought of as a specialized piece of tissue, which I describe in the voiceover PowerPoint as being partial cardiac muscle, partial nervous tissue. I can't speak to any more specifics as to that tissue. You can certainly go online and learn more about it if you want, but for now we're just thinking of the SA node in the upper part of the right atrium as where these impulses originate, and then of course pass through the atria first, and then down the interventricular septum, and then up into the ventricle walls, right?
Okay.
Yeah.
Yeah.
But as a sneak preview, and this relates to what Sarah was asking, our nervous system can influence the SA node. So when we talk about, say, fight or flight response, okay, that occurs as a result of certain nerves sending more impulses, they're called sympathetic impulses, to the SA node, and that increases its activity. And so your heart rate speeds up as a result of that.
Okay.
There's also at the base of the right atrium something called the AV node. And that can also be affected by nerves as well, both speed up and slow down. In fact, I've also read where if there's, say, damage to the heart and the SA node is damaged, the AV node will try to pick up where the SA node left off, if you will, in an effort to maintain one's life. And I'm not exactly sure, how that works, but I have read that.
That's kind of neat.
Yeah,
That
very
is
interesting.
cool.
Oh, the heart's just an amazing organ. Yet we abuse it sometimes by not getting enough exercise or whatever the case may be.
Drinking too many energy drinks.
Yeah.
Now, how does like AFib correlate with? I'm not sure what I'm trying to say, but I'm trying
Yeah.
to
I
how that goes.
I can't speak from a clinical standpoint. What fibrillation is uncoordinated activity, contractions of the heart. So if the atria go into fibrillation, they're not pumping the blood into the ventricles like they should. And so, where have you encountered it?
My boyfriend was in AFib for probably 2 months.
And what did they do?
Well, they first gave him, I'm not sure what pill they gave him to try to get him out of AFib, and that didn't work. And then a month later, they actually did a cardio version. That, thank God, worked.
They did a what version?
Cardio version.
Explain that to people who don't know what it is.
They put him under a local anesthetic and used the defibrillator and shocked his heart at a low voltage to get it back, like basically restart it, I guess.
So he walked into the hospital in AFib still, and they put him under and gave him a shock, and he walked out smiling.
Yes.
And he hasn't had any issues since.
Nope.
See, it's like going to Jiffy Lube.
Yeah. It's funny though, because now though, he every once in a while will say to me, I feel like I'm in AFib again.
Yeah.
And he'll have me check his pulse and everything. And I'm like, no, I can't tell. I can't feel it in your pulse this time like I could last time.
Uh-huh.
But it's almost like his heart still kind of wants to go back to that.
Does he describe it as a fluttering?
Well, like when he had it the first time, he swore to God he had like bronchitis or pneumonia because his breathing was so bad. He didn't really notice anything like fluttering in his heart. It was his breathing that alerted him to it.
Wow. Huh. Yeah, I know of it. I don't know specifically, what the cause is. Really not something you want to have, for a long time.
No, definitely not. I know they do say like sleep apnea tends to throw you into AFib,
Uh-huh.
like untreated sleep apnea.
Mm-hmm. Guess I better be careful.
I definitely need to get my husband in to see a doctor.
Well, with my boyfriend, what it was is he had gone, 3-4 years with untreated, extremely high blood pressure. And that's what I attribute it to, even though he has sleep apnea that's undiagnosed. So, but he hasn't gone back into it since he's been on his blood pressure medication.
Uh-huh. Uh-huh.
So
yeah, I guess
I use it as a scare tactic.
Yeah, you have to ask his physician exactly what the connection is between, the maintenance of blood pressure and AFib. I just don't know. How old is he?
He'll be 49 in June.
Okay, so he's not that old.
No, and he had it, he was 46 when he had it.
Is there a history of that heart disease in his family?
Yeah, his dad had quadruple bypass probably 15 years ago. His grandmother had geez, now I'm drawing a blank on it. She had heart disease. What did she?
It often runs in families, doesn't it?
Yeah, well, and that's why I'm on him so much about it.
Yep. Yep. That's good. Somebody's watching out for him, right?
Because we all know.
Unfortunately, all of us wives and girlfriends.
Right.
That's what I was just gonna say, Sarah. If it wasn't for us, they wouldn't do it.
No.
All right. Well, our time is up. Any last minute questions before we?
Yeah, no, I'm good.
Okay.
I'm good
Sarah?
for today.
All right, great. Sarah, you want to stick around and we'll talk after everybody else gets out?
Yep.
And she has a question she wants to ask me. Okay, well, we'll see the rest of you guys then Wednesday.
Have a good day.
You too. Definitely get into that chapter and look at those voiceovers.
All right.
Okay, thanks.
Bye.
Bye.
Thank you.
Sure. Okay, Sarah.
Okay, for the exam, number 29, it says, on average, what % of blood's volume is composed of plasma? The book says 55%, but it marked me wrong, saying it was 45.
Okay. Okay, so let me go back and look at that. That was question 29.
Yes.
Okay. I will double check that. But you were able to get in and look at the exam, right?
Yes.
Good. Great, great. Was that it?
There was one more. I'm just not sure if you're doing the partial credit or anything. Because number 37, I put uvula and trachea, but it was epiglottis and trachea.
Should have got half.
That didn't give me any.
Okay, I'll take a look at that one too.
Okay.
Yeah. Good to go in and look. That's why you should be looking, see, and make sure things are kosher.
Okay.
All right, very good. I will check it out.
All right. Thank you.
Okay, Sarah. See ya.
See ya.
Yeah, bye.